Let's continue here on deriving exponential functions. We're looking today, or in this part, if the base is the number e. Okay? And so here I've written the exponential function derivative, and we're going to apply that when the base is e to the power x. Okay, so grab my pen. The derivative then here is going to equal b to the power of u, so e to x. E is the base, u is the exponent, times the natural log of the base, natural log of e, which we know is equal to 1, times the derivative of u, or the exponent. The derivative of x is also 1, and this equals 1 too. Remember, this is log base e of e, we know, equals 1. So the derivative of e to the power of x is e to the power of x. Here's a funny joke. Read this, it'll change you. It says x to x squared. And x squared reads it. Look at his expression. He's wowed, and he changes to 2x. His derivative is 2x. Then 2x says to e to the power of x. Read this, it's going to change you. It's so amazing. ex reads it. Meh, it was alright, I guess. He throws it back. How could anyone not be affected by this book? Says 2x. And the book is the derivative. Funny. Yeah, if you want to read it again, just pause it and go back and watch it again. Okay, so here's what we talked about. If the function we're looking at, the exponential function, is base e to a certain power, the derivative will be itself multiplied by the derivative of u, whatever u happens to be. Okay, so let's apply that. Derivative here is going to be itself, coefficient e to the half x, multiplied by the derivative of the exponent, which will be a half. So the derivative here is 5e 1 over 2 times x. Let's move over here so we've got enough room eventually. I've rewritten it again with this denominator in the numerator and making the exponent negative. Okay, the derivative here of y. Okay. Itself 5e to the negative 2x multiplied by the derivative of the exponent, negative 2. So we see negative 10e to the power of 2x. Okay, looking at the third one here, we see we're going to have to use the product rule. Here's the first term, f, and g. Okay, I'll let you set that up with your f prime, your g, and your g prime. Okay, so we found y prime here by multiplying f prime times g plus f times g prime. Once we did that, we took out a common factor, and we're left with this whole string. Notice this 3 has been distributed as well to get this. Then we gathered like terms. Now, this, I think, is factorable. Multiplies to positive 18, adds to positive 11. Yes, 9 and 2 do that. Do decomposition here, and you should arrive at the final answer of e to the power of 3x, and the two factors will work out to be 3x plus 2 times x plus 3. And there's the derivative of this function here. Okay, moving on to the last one. Quotient rule, right? Let's set that up. F prime, g prime. Go ahead, find those, and then we'll do it together. Okay, I erased things and wrote down this derivative for a natural log that we need for this last question. Okay, so this is what you just found, and we use the property of finding the derivative base e to a power of x here. Remember, the derivative is exactly the same, and the derivative of x would be 1. So now let's find, we're working on number 4 here, derivative of y. This is the natural log, so here's the natural log formula. Form 1 divided by u. In this case, this is u. Remember, when we divide 1 by a fraction, it reciprocates. So we're left with e to the power of x minus x all over e to the power of x plus x. That's 1 over the u multiplied by the natural log of u. That's an error, not the natural log of u. That should say the natural log of e right here, which we know to be 1. And then multiplied by the derivative of u, in this case here. Now the derivative of u is where we need to use the quotient rule. So here we've got derivative of f multiplied by g, subtract f, multiplied by the derivative of g, all over g squared. Okay, right away now, as usual when this happens, this factor cancels out with one of those. Okay, let's multiply these binomials together in the square brackets. Let's see what happens here. Okay, we should have e2 to the x. Remember, we add the exponents here when we multiply same bases. Subtract ex times x plus e to the power of x, subtract x, subtract e to the 2x, plus e to the x, subtract e to the power of x times x, plus x. Okay, remembering that this negative, after I FOILed this, I multiplied this negative through. That's where these signs changed. Okay, and that is all over ex plus x. That's from here, multiplied by ex minus x. Okay, that's good. Now some things will cancel out here. We've got e to the 2x, subtract e to the 2x. We've got positive negative x plus x. That's good. Okay, let's gather like terms and take out a common factor. You can do that. So you can see here these are conjugates. I multiplied them together to get this. And then these two terms that were gathered, they have a common negative 2e to the power of x. We factored that out. And here's your answer, the derivative of this function. Let's move on to the next page. Turn it over. Here we have 4 properties of logs and natural logs and exponents that we're going to highlight and we can make use of in your assignment. Okay, so the first one says the log base b of b to the power of u. When you see this, the answer will always just be u. We can accept that property. So which one does it match up here? Well, here we see log base 5 of 5 to the power of 7 x plus 9. This matches with this one. And using that property then, when I see this, I can know that the answer is going to be u, that exponent. Okay, let's look at the next one. The natural log, which we remember as the log base e of e to the power of u, which matches this, we can use that property to know that when we see this form, the answer will be u. So here we see this, the answer is, or how we can simplify it is using that property as that. Okay, number 3, when we see a base to the power of log, with a base b of u, that simplifies as simply u. And that is this property shown here, base 3 log base 3. This will simply equal x squared minus 9. Lastly, property number 4, this is the one that's shown in our next questions. E to the power of the natural log of u will be simplified as u. That's here. E to the negative log 10 will simply be, now they've thrown an added trick to this one. U in this case is 10, right? So you'd think the answer should be 10, but they've thrown in this negative in front. You know, remember the negative on an exponent does what? It reciprocates it. So our answer should here be 1 over u, or negative u in this case. Okay, let's move to the last two examples on the bottom of this page. Look right above. This is an example of property number 4. Okay, so property number 4 says that when you see e to the power of the natural log of u, the simplified version of this is u. So we can rewrite this expression before we find its derivative, and once we've done that, it's a pretty simple derivative. The answer would be 4. Property 4 is also shown in this example. Again, now, we can rewrite this as x being multiplied by, here's where property 4 comes into play, e to the power of the natural log of u. Now we know that this equals u. What is u in this case with this over 2, etc.? Let's see if we can think about that for a minute. This is the same thing, and this exponent is a half times the natural log of x, right? Property rules of logs and natural logs say that this coefficient can be rewritten as the exponent. So this is the same thing as writing x to the power of a half. Okay, now we can use that rule. So what we've got here is x times e to the power of the natural log of x to the power of half. We know that this can be replaced with u, so we've got x right from there. This can be replaced with x to the power of a half. Then we can simplify it further. Remember, if we have the same bases like these are, this is being multiplied, we add exponents. So 2 over 2 plus 1 over 2 is x to the power of 3 over 2. That we know we can easily take the derivative of. That's the elementary differentiation rule. 3 over 2 minus 2 over 2 would be 1/2. And we can write it that way, or we can write it as 3 root x over 2. Okay, so your assignment for this section, you can look to continue on page 311. Please let me know if you have any questions as you're working on your assignment or as you're working through the optional check. Remember, it's better to ask when you're in the middle of it and figure it out. Good luck.